Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, Palindromic substring. So let us first read this question, then about constraint, and then finally the coding part for the same. So let us first read the question which is given to us. So here we are given a string s, return the number of palindromic substring in it. A string is a palindrome when it reads same backward as forward. A substring is a contiguous sequence of character within the string, and we are required to return palindromic substring. So palindrome is ABA, right? Where we are, if we are reading from this, means if we are standing at this point and reading this, so it is same. And if we are standing at this point and reading this, it is also same. So that is what it meant by this. And about the substring simply refers to that this AB is one substring, then BA is one substring, and ABA as a whole is also a substring of the string ABA. So these are the things, means just the general knowledge of the question if you are completely new. Now comes the part for the constraint, because before approaching anything we should check for the constraint. So now here we can see the constraints are that this character which is there that could go up to 1000 only, means basically length of the string which is there, character count can go up 1000. So as per that, if we iterate this, right, it is 10 raised to power 3. If we iterate this and if we go ahead with n square solution, then it will work. But if we go ahead with n cube solution, then it won't work. So basically, at max, the time complexity should be n square. That is at max. It could be n log n also, or n square also. Now this was all for the constraint. Now let us first read this question. So here we are given ABC. Now we are required to check how many palindromic substrings are there. So here if we check a character itself is a palindrome. That is for sure. So A is a palindrome. Then we check AB, it is not a palindrome. Then if we check ABC, it is not a palindrome. Then if we check BC, it is not a palindrome. But if we check C, it is a palindrome. And now comes the part for B individually. Yeah, B individually is a palindrome. So here we are having three palindromic substrings. Now we go ahead with this AA. So here this AAA, first all separately are a palindrome as mentioned. Now there is AA and this one AA, and then this as a whole, and because of all these combination it becomes 6 ways that we are able to get a palindromic substring. Now this was the general about the understanding of this question, but now comes the part that how you will be solving this question. So if we go ahead with the complete brute force approach, what comes to your mind? The thing which comes to your mind would be that first thing is that we are required to count substrings, and the second thing is those substrings should be palindrome. So we are required to figure out all the substrings which are basically palindrome. So this is how we can go ahead with a brute force solution, and how that could be. See, if we go ahead with n squared loop, right, for counting the substrings. So for that purpose, we can start from I equals to 0 and j equals to I, and both will be going till n where is length of the string, right? And these are the nested loops. Yeah, these are the nested loops. So in that context, if we check now, because of this, we can simply give a particular window, that in this window, like if I equals to 0 and j equals to I, right? So the number itself, then when j increments, then up to 1. So the window of 0 to 1, we need to check that AB is a palindrome. Now this will be a separate function that we are required to check if it is a palindrome. And then palindrome itself, the palindrome checking itself, even if we use a 2 pointer, right? So in that context also, the palindrome checking itself will take order of n. So overall, this solution will become order of n cube. and this is our brute force solution. But as per the constraint which were mentioned, that the string could go at max till the length of 10 raised to power 3, and because of this we can only go ahead till 10 raised to power 6, not more than that. Means basically, if this is n, then we can only go ahead till n square solution, else after the n square solution it will give us TLE. So because of this approach which we call as the brute force, now we are required to basically optimize this brute force solution. And for optimizing that brute force solution, how we can do that? So now for doing that thing, what we can do is, like, rather than going ahead with the n square, means making so many substrings, we can cut out at the starting only that if this is a possibility or not. Basically, we can first check, means whatever here recursive things we are doing, that we can simply memorize. That is what we can do, and in that also we can tweak this brute force solution. How we are required to tweak is that we will checking to from the ends, means we will be having one pointer for this and one pointer for this, and we will be at the start we will be checking that if the first means zeroth and the nth, means basically n minus 1, if they are not equal, at that point only we will exit out, so that it directly can return false. Because after all, if at that point of time it is not able to check if that particular substring is a palindrome or not, then surely we can check it out and go ahead with the next iteration. And then like this only we will be moving ahead, and overall we can make a n square solution. And now I can show you that how we can make n square solution. But before going to coding part, let me explain you more. So basically, here if we see, this was n cube which I had already told. Then for approach 2, what we can do is we can check for single character, marking them as center for odd length substring and expand around the center. Basically, we can just check because a single character itself is a palindrome, right? So in that context, how we can do is we can simply take a single character and expand around that, so that we can check that. And that last and end thing which was there, if we are expanding around a center, then it can easily let us know that it is a palindrome or not. See how earlier we were doing was, 1 minute, I can directly show you. So earlier we were doing was that we were starting from the start, right, and going till the end. Now how now we will be doing is, although we will be starting from the start, but we will be expanding around this. That is the thing. And because of this, if you clearly see this thing, if we are expanding around this, right, so if both of these are equal, then it is surely a palindrome, because this particular character itself is a palindrome. And if same characters are being appended in front and end, then the whole substring would be a palindrome. So this approach we will be following. Now the next thing is that check for pairs for even length substrings and expand around the center. Now this was for the odd length. Now for the even length, how we will be doing it? We will be checking for the pairs of even length correct substring and expand around the center. So basically, if we have a pair of AA, right, and then we will be checking for BB. Means basically this will be our center, means a pair would be our center, and we will be expanding around that center. This is how we will be doing. So now for this particular solution, accordingly, whatever edge cases would be there, because here when we are expanding around this zero, there is surely a edge case that left hand side is not existing, right? And if we are expanding around n minus 1, right? So that is also the case that on the rightmost side there is no character, right? So all those edge cases would also be required to be handled, and then we can directly go ahead with the n square solution. Basically, here we are not explicitly checking for a palindrome, but as we are expanding around the center, that's why by itself we are able to check a palindrome, and that is how we come from this n cube complexity to directly n square complexity. So if you are able to understand the solution, that how we are going to do is that expand around the center. For odd length, it would be a single character, and for even length, it would be a pair around which we will be expanding. And if you are able to understand this, you can go ahead and code the solution. Before that, you can go ahead with the brute force as well. But yeah, as it will give you TLE, so you are required to go ahead with n square solution, and that is how you need to do it. So now, if you are able to understand, you can go ahead and code it. If you're not, then rewind the video and check the explanation. Else still you are not able to check, then I'll show you the solution of the same. Means basically you can go ahead and check the solution. So here is my solution, which was for the brute force. That was checking for the palindrome, which I'm doing here. Is this all is checking for palindrome, which makes its order of n, and this is checking for each substring n square. Right now, this is the memoized version that is expanding around the center. So here, starting from the 0th point, and here itself the string we are giving it and the indices of low and right, which would be basically expanding around the center. And this is for the when it is equivalent, this is for the pair, means basically I plus 1, that would be we are checking for two characters, and whatever count it will be returning, because this function is returning a count, so it would be added up to answer. This is a wrapper. Now comes the next part. Now here, as we are expanding around the center, so we will be keeping a while loop which checks if low is greater than 0 and high is basically less than size of a string which has been passed. So that edge cases are handled. For the case of low, basically it doesn't go towards the left of 0 and it doesn't go towards the right of n minus 1. So here at the first only, we will check if low and high are not equal, then surely we will be break out of that, because they are not equal, thus they are not qualifying the palindrome criteria. Means if it would be AA, then it is qualifying. If it is not AA, if it is say AB, right? Here if it see if it was odd length, right? So both are I, then surely it will qualify, right? If it is even length, right? So for that we require I plus 1, right? But for that purpose, if it is AB, then we won't be qualifying and breaking out of the loop. But if it is A, both of them are A, then at that point we will be just going ahead with the solution ahead. So in that context, if it qualifies, then we will be decreasing the low and increasing the high so that we can check the next string which is there. And as it has already qualified, right, because it hasn't break out from this, so we got one palindromic substring, thus incrementing the answer. And then at the end, we are returning the answer so that we get the count till now, and that count we will be adding up in this answer and returning the answer. So here you can clearly see that this is order of n, right? And this is also, it can at max go till order of n. So overall time complexity becomes order of n square. Now comes the part for the space complexity. So space complexity, you can clearly see that we are not using any extra space, so it becomes order of 1. So this was all for this particular solution. If you have any doubt, you could comment that down. And if you really like the solution, you can like, subscribe and share this video among your friends. So this was all. Thank you.